When we look at credit card numbers and cell phone numbers, we really wonder how they are uniquely arranged for each person. Of course, the permutation is very much helpful to prepare these numbers. Also, when we come across the number plates of vehicles which consist of few alphabets and digits, we can easily prepare these codes using permutations. Permutation is the arrangement of objects in a particular order. It can be classified into three main categories. Let's see one by one. First one, permutation of n different objects where the repetition is not allowed. Second, the permutation of n different objects where the repetition is allowed. And the third one, the permutation when the objects are not distinct. That means the permutation of multi-sets. So, let us understand one by one in detail. First, we will discuss about permutation of n different objects where the repetition is not allowed. If n is any positive integer and r is a whole number, the permutation of n different objects taken r at a time where r is less than n, when the repetition of objects is not allowed, is represented as P of nr is equal to n into n minus 1 into n minus 2 into n minus 3 up to n minus r plus 1. That is, P of nr is equal to n factorial divided by n minus r factorial. Let us look at an example. How many three-letter words with or without meaning can be formed out of the letters of the word computer when the repetition of letters is not allowed? Solution. Here we can see that n is equal to 8 as the word computer has 8 letters, right? Now what is r? R is equal to 3. Since we have to frame 3-letter words with or without meaning and without repetition. Alright. Now the total permutations possible are P of nr is given by substituting the n and r value in the equation, that is n factorial by n minus r factorial. We get 8 factorial divided by 8 minus 3 factorial, which is equal to 8 factorial by 5 factorial. Now we have to expand it. We get 8 into 7 into 6 into 5 into up to 1 divided by 5 factorial, that is 5 into 4 into 3 into 2 into 1. And we get it as 336. Now we will look in detail the second category, that is permutations of n different objects where the repetition is allowed. So here when the number of objects is n and we have to take r objects from this n, then choosing the object can be in n different ways. Thus, the permutation of objects when the repetition is allowed will be equal to n into n into n into likewise r times. So, this can be written as P of nr is equal to n to the power r. Alright. Now, let's look at an example to understand this more clearly. How many 4-letter words with or without meaning can be formed out of the letters of the word mother when the repetition of words is allowed? Let's see the solution. Here, the number of objects, the n is what? In this case, it is 6, as the word mother has 6 alphabet. And what is r? R is equal to 4, as we have to choose the 4-letter word. Now, the permutation when the repetition is allowed will be given by P of nr is equal to n raised to r. Substituting the value, we get 6 raised to 4, which is equal to 6 into 6 into 6 into 6, and we get it as 1296. Now, we will discuss about the last category, which is permutation of multi-sets. Permutation of n different objects when P1 objects are of one kind, P2 objects are of second kind which are similar, P3 objects are of the third kind which are similar, and so on. Likewise, Pk are of the kth kind are similar and the remaining are all of a different kind. In such cases, we can say this, it forms a multi-set. And here, the permutation is given as n factorial by p1 factorial into p2 factorial into up to pk factorial. We can understand it clearly by looking at an example. Question, find the number of permutation of the letters of the word textbook. Let's see the solution. Here, there are 8 objects as the word textbook has 8 alphabets. So, our n is equal to 8. Now, there are 2 T's and 2 O's and rest all are different letters. Alright. So, here the required number of permutation is given by 8 factorial divided by 2 factorial into 2 factorial because 2 T's and 2 O's. So, expanding them, we get 8 factorial and 2 factorial, 2 factorial. Here we can cancel and we get it as 8 into 7 into 6 into 5 into 3 into 2 and the final result comes out as 10,080. Hope you all understand how these methods of permutation are helpful in our real life, and this is how we get such unique card numbers. The same method is used in the lottery, also in log systems, etc. So try to find these kind of real life applications of permutation which will be helpful to understand it more clearly. Now we will summarize the concepts which we have covered here.
Manorama Horizon, learning made simple.